Functions. An activity or purpose natural to or intent. What's that? Wrong definition? Oh yeah, this is a video about. According to Merriam-Webster Dictionary, functions in mathematics are a mathematical correspondence that assigns exactly one element of one set to each element of the same or another set. One example of this could be the amount of time a person runs a faucet versus the amount of water inside a 20-liter maximum capacity bucket. The variables in this function are the input variable, the amount of time the faucet is running in this case, and the output variable, or the amount of water inside the 20-liter maximum capacity bucket in this case. Input variables are what goes into a function, or what you put into it. It is also known as the independent variable. For this example, it will be represented with x, which we're gonna substitute. This is basically what you control. The output variables, meanwhile, are what come out of a function, or the result of it. It is also known as the dependent variable. For this example, it will be represented with y. This is basically the response to the input. So, say that it takes faucet guy 5 minutes to fill the bucket. Then the equation for calculating this would be f of x equals x times 4. Since the bucket takes 5 minutes to fill and has a maximum capacity of 20 liters, and 20 divided by 5 equals 4. F of x equals x times 4. If we substitute x with 1, so with 1 minute, then f of 1 equals 1 times 4. And since f of x is just the function we use to find y, then y equals 4 liters. This would mean that faucet guy ran the faucet for 1 minute, which is the input, and it resulted in the bucket being filled with 4 liters of water, being the output. And then we can keep increasing the number to substitute x with until we reach y equals 20. So f of 0 equals 0, so f of 1 equals 4, f of 2 equals 8, f of 3 equals 12, f of 4 equals 16, and f of 5 equals 20. The domain and range. The domain in this example would be the numbers 1, 2, 3, 4, and 5. The domain is the set of all possible input values. The domain in this example represent the number of minutes in which the faucet is left to run. The range in this example would be the numbers 4, 8, 12, 16, and 20. The range is the set of all possible output values. The range in this example represents how many liters of water are in the bucket after the number of minutes given as an input. Now, how can we represent this function? First, we can represent it with a mapping diagram. A mapping diagram illustrates the relationship between the domain or the inputs and the range or the outputs, using two parallel columns and arrows that connect corresponding pairs of values. We can also represent it with a table of values. A table of values is a table that shows the domain and range of the function using columns and rows. And we can also represent it as a graph. A graph is another visual representation of the function's inputs and outputs using a coordinate plane and interpreting the pairs of x and y values as coordinates. With our representations of the function, we can also easily identify other characteristics of the function. We can tell that the function is a linear function because if we look at the graph, it is a straight line. We can tell that the function is increasing using the graph as the line follows the increasing values. We can also use the table of values to easily tell that the function is increasing as the values of both x and y increase simultaneously on the table. You can easily tell that the function is one-to-one using the mapping diagram. Now, how did understanding functions help me make sense of this real-life situation? Well, understanding functions has indeed helped me more easily calculate how much time exactly it would take to fill the bucket of water. Thus, with functions and more specifically linear functions, you can easily calculate patterns which scale up or down, such as this one. Studying functions also gives you tools for easily illustrating these patterns in a way that's easy to understand with the use of graphs, tables, and mapping diagrams. Hypothetically, had I calculated how long it took to fill the water to 1/5 capacity, which is 4 liters, I would have also been able to fill the bucket all the way to 20 liters without a single drop wasted and without having to monitor it simply with calculation. Thank you for listening. I hope you enjoyed or learned something from this presentation. That's it. Okay, thank you. Bye.